Good day everyone, my name is Kato Wiled of ECE 3A, and today I am going to demonstrate and describe to you the values being displayed on the 7-segment display from 0 to 9. So the general concept, excuse me, the 74447 was connected to 74151 since it accepts 8 inputs and produces 1 output. The output has 2 lines, the Z and the Z prime. But in this lab, only 7 inputs was utilized. The 74151 was used along with the 74138 with the purpose of demultiplexing, or in machine language, we can say as decoding. The 3 inputs from 74151 is connected to a clock, and it is also the input for the 74138 to convert it into an 8 output. But in this laboratory, it's only 7 outputs. The other input, D7 and Y7, was connected to a 5K ohm resistor to the ground, since we only need to drive a 7-segment display. This also applies to 74138. Then the 7 output from the 74138 was connected to a 7404. Since we are driving a common cathode, it is utilized to switch the logic states of either the active high or active low. Then the outputs from 7404 is connected to current limiting resistor. So let's now simulate and describe. If we put 000 as BCD input in our circuit, the number displayed in the 7-segment display will be 0, because the input combination, in this input combination, the segment A, B, C, D, and F are active. So if we input 1, 0, 0, 0 in the circuit, the number displayed in the 7-segment display will be 1, because in this input combination, the segment B and C are active. So if we try to put 0, 1, 0, 0 as BCD input in this circuit, the number displayed in the 7-segment display will be 2, because in this input combination, the segment A, B, G, E, and D are active. Next, if we try to put 1, 1, 0, 0, the number displayed in the 7-segment display will be 3, because in this input combination, the segment A, B, C, D, and G are active. If we try to put 0, 0010 as BCD input in the circuit, the number displayed in the 7-segment display will be 4, because in this input combination, the segment B, C, F, and G are active. Next, if we put 1010, the number displayed in the 7-segment display will be 5, because in this input combination, the segment A, C, D, F, and G are active. So if we try to put 0, 1, 1, 0 as BCD input in this circuit, the number displayed in the 7-segment display will be 6, because in this input combination, the segment C, D, E, F, and G are active. If we try to put 1, 1, 1, 0, the number displayed in the 7-segment display will be 7, because in this input combination, the segment A, B, and C are active. If we try to put 0, 0001, the number displayed in the 7-segment display will be 8, because in this input combination, the segment A, B, C, D, E, F, and G are active. If we try to put 1001 as BCD input in our circuit, the number displayed in the 7-segment display will be 9, because in this input combination, the segment A, B, C, F, and G are active. So in this activity, I was able to learn the pin configurations of common TTL multiplexers in demultiplexers. In multiplexers, we have 741151 and 74150, while in excuse me, in the multiplexers, we have 74138 and 74159. Upon analysis, I realized that a multiplexer selects binary information from one of many input lines and directs it into a single output line. Contrary to that, the multiplexer accepts only one input and gives many output. Demultiplexers was used along with multiplexers. Moreover, digits displayed blinked by implementing this circuit. And the clock and a clock with a carefully selected frequency, it visibly displayed the corresponding value in the 7-segment display blinking. With continuous research, I gained more knowledge, adding to my foundation in the IC used and other components.